entity is a thing. Could be a person, could be an order. And we represent entities in databases as tables. So an entity, you may think of actually as an entity as an individual. Here we treat it as a group, if you like, group of individual records, individual people, orders, and that becomes our table in our database design. So entity formally refers ultimately to a table. The entities, or tables, have attributes. So an attribute is, if you like, if it was a spreadsheet, that would be the columns of our spreadsheet. So it could be a person's name, it could be the value of an order, it could be the date. So all of those things are descriptions or attributes of our entity. We need to uniquely identify each of the records within our entity, and for that we have a thing called a primary key. Now the primary key is the unique identifier that's going to be that core value or values that identify the individual record of that entity. The primary key can actually be made up of multiple columns, so it may be that it's a single column, it could be my employee ID, but it also could be multiple columns. And often we'll have a scenario where you say, okay, that value on its own isn't unique, none of the values are unique, but a combination of values become unique. Something plus a date makes it unique. An order plus the customer in combination might make it unique. So we have multiple columns, and we can have two or more columns providing a primary key, and that's called a composite key. When we're actually creating these things, when we're designing those things, we start with things called candidate keys, because often there'll be multiple different columns that you might think are suitable as a primary key. You can only have one primary key, so we have to then have a look at the candidates, and then we have to justify which one of those is the best primary key from our data. Now, of course, if we have multiple candidate keys, there may be multiple suitable columns or suitable attributes that could be used as a primary key. And if we retain those values, we may well have surrogate keys as well. So that's where we have another column. It's not a primary key, but when we're looking at the design, we might want to just check that normalization rules work with surrogate keys as well. An example of that would be that you have in a car a vehicle identification number and also a license plate number. Both unique identifiers for the car, both values we want to store, only one of them is the primary key. But actually, when we do normalization rules, let's just check they work if you switch, and if you use an alternative surrogate key, because normalization should still work with that as well. So that's just covering some of the key things around that individual table. Now, when we're looking at normalization, those attributes that we have can have dependencies. They can actually depend on each other. And actually, when we're going through and performing our normalization processes, what we're looking for a lot of the time is these dependencies. Now, a dependency is where something can be derived from another attribute. So, for example, I could say, I can work out the employee's name because in that table you've got the employee ID. In an order table, the salesperson ID is in there. If you had salesperson name as well, that would be a dependency. The salesperson name is dependent on the salesperson ID. I give you the ID, you can tell me the name. Okay, that's a dependency, and that's one of the key concepts we're going to use when we do normalization. So those are just some of the key terms that we use when we look at normalizing our database.